Hello, BJJ listeners. I am Andrew Duck, and a warm welcome to our third podcast from your team here at the Bone and Joint Journal. As many of you know, the aim of our podcasts are that we will improve the accessibility and visibility of the studies we've published for both you as our readers, as well as for our many authors. During the next 15 to 20 minutes or so, we hope to discuss a range of aspects of the chosen study, emphasising some of the important points and how the work has been designed, as well as the key findings from the study, and almost give you a behind-the-scenes insight into how the authors have developed their work. As part of our BJJ podcast series, we plan to utilise the invaluable insight of certain guest interviewers to select papers. So today we have a slight variation on our normal setup, and I have the pleasure of welcoming our first guest interviewer, Sam Patton, who is my colleague here in Edinburgh and also our subspecialty editor for oncology at the BJJ. Welcome, Sam, and thank you very much for joining us.
Thank you, Andrew. Thank you.
Sam and I are delighted today to be joined by Professor Ajay Puri, who is speaking to us all the way from the Tata Memorial Centre in Mumbai in India, about their paper entitled Neoadjuvant denosumab, its role and results in operable cases of giant cell tumour of bone, which will be published in the February 2019 edition of the BJJ. Welcome, Ajay, and a big thank you for taking the time to join us.
Thank you, Andrew. Thank you, Sam, for having me here, and it's a pleasure to be able to speak to you.
Well, Ajay, we'll just move on with the paper now. And obviously, I think both you and I spent some time during our formation working at the Tumour Centre in Birmingham. But I think that's really where the similarities end. And obviously, I currently work in an outpost which is frozen somewhere north above Hadrian's Wall. And you're working in a developing megacity in India. So I'd just be grateful if you could share a little information with us about what the setting for this study was.
So just as you said, I work in a small seaside town called Mumbai that has a population of 24 million. So I work at the Tata Memorial Hospital, which is a tertiary oncology center. We are, if I may say so myself, one of the prime oncology centers, and we deal with only cancer, all sorts of cancer. Now, we know that India has a population of 120 billion. So being a tertiary referral center, my patient base essentially encompasses referrals from all across the country. And that is why what we see, what seem like unrealistic numbers. So just to give you an idea, we register about between 2,000 and 2,200 new sarcomas a year. And we see a close to 200 osteosarcomas a year. And that is why the numbers that we are going to talk about may seem a little unrealistic, but that's the ground reality. Because we don't have that well-developed orthopedic oncology units all across the country. And therefore, we get a referral from a large geographic area. In fact, just less than about 15 or 20% of my patients would come from the city, coming from outside Mumbai, the state, and the rest of the country. We are a government institute. It's not a private institute. Our treatment is highly subsidized. And this will be sort of more relevant when we talk about the cost of denosumab as we discuss the paper. So the medical care, the in-house facilities are essentially very subsidized, almost free of cost. But the patients do have to pay out of pocket for drugs that are used or for an implant that is used.
Okay, I mean, those are extraordinary numbers, AJ, and, congratulations to you. You have a fascinating experience, and you can always tell the basis by any oncology center by the population really that it serves. Just in view of this huge experience that you have, could you tell us a little about your standard treatment for ordinary giant cell tumours that you've been using up until now?
Now, giant cell tumors, as we know, though they are locally aggressive, they are essentially benign tumors. So unlike malignant tumors where we are very certain that we want clear margins, in giant cell tumors, we are willing to accept a bit of a compromise in order to retain function. And therefore, we would like or prefer to do intralesional surgery or curettage for a large majority of our tumors rather than do wide resections, Because these generally occur in a younger age group. The average age group, even in this set, was about 25 to 27 years. And so these are patients who with benign tumors are going to have a very active lifestyle. And therefore, if we do a resection and replace with a mega prosthesis, they are going to be subject to an X number of revisions in their lifetime. So our general plan is that wherever possible, and even sometimes extending the boundaries of possibility, we will prefer to salvage, retain the host bone, do an intralesional curettage rather than avoid resection. Over the period of time and with increasing experience coming from literature, we do not use additional adjuvants during surgery. What we do is an intralesional curettage, a mechanical high-speed burring, and then either fill in the cavity with bone cement or bone. We are fortunate enough to have a bone bank in our institute, and therefore we have access to large quantities of bone if we need to do that. Wherever after curettage we believe that skeletal integrity would not be retained or adequately established to retain host bone, those are the cases where we do a resection, but that would be a smaller percentage of cases compared to where we would do intralesional surgery or curettage.
Good. Okay, so you're not using anything like liquid nitrogen or alcohol or anything as an adjuvant. You're essentially either just leaving the cavity to bone graft, or you're using cement, as it were, as your adjuvant. Is that correct?
We began the unit about 2 decades ago, intralesional adjuvants like phenol, alcohol, but based on our own experience and what literature did show us, that doesn't really seem to make too much of a difference. The sort of real taste of the, or would say the test is if you do an adequate curettage or no. If your curettage is inadequate, it's unlikely that adjuvants will bail you out.
Okay. Now, of course, what we have now is there has been a whole series of very clever tailor-made drugs aimed at various pathways, and we've seen an extraordinary rise in these drugs, and they are now starting to do all sorts of interesting things for us. And denosumab came in really with a fanfare, and we thought it was going to be a magical answer for giant cell tumor, didn't we? So can I just ask, just really for the benefit of our listeners, can you tell us what denosumab is and when you started using it?
If you look at giant cell histologically, it contains the giant cells, but the actual neoplastic cells are the stromal cells. Denosumab is a fully human monoclonal antibody that specifically inhibits the rank ligand. And this rank ligand, which is expressed on the neoplastic stromal cell, is what actually promotes osteoclast formation that causes lysis of bone. So by inhibiting this, what we are doing is decreasing the osteolysis, not allowing the osteoclastic giant cell to lyse bone and help in bone formation. What we have realized over a period of time is that it does not actually target the neoplastic stromal cell. And therefore, as rightly said, denosumab, which was thought to be a magic bullet that would solve all our problems in giant cell tumor, hasn't done that. Yes, a very good drug, but as we will discuss further, there has to be judicious selective use of that drug now. Coming to what you said, we were in a way fortunate that denosumab became available in India a little later than what it became in the West. And therefore, we could learn from the experience of our colleagues when we met at meetings, the problems that would possibly come with denosumab. And therefore, we were in a way lucky that being late onto the bandwagon, we were able to make more judicious use of it than what was thought of earlier in the earlier trials.
So when did you actually decide to use the regime that you've adopted in this paper, Ajay?
So denosumab became available in India in the late 2013. So the series that we spoke of is beginning January 2014. And the regime that we have used was not something that was decided with us, but because this was a new drug, this is the regime that was propagated in the initial phase 2 study that spoke about denosumab going. So we directly lifted the sort of regime of that phase 2 study because we had no experience, and we thought rather than play around with dosage and duration, it's best to go with what has been published and what has been used as being efficacious in giant cell tumor. And that was the reason why we went with this sort of regime.
Okay, so you've chosen three main groups of patients for treatment in this study. And I understand that you've selected a particular cohort of patients who come to your institution for treatment. So how did you choose those groups, and why did you choose those groups?
Referring to what I said at the beginning of the talk, the patient has to pay out of pocket for denosumab, and denosumab is inexpensive. In Indian terminology, it costs about, I think, the equivalent of £200 or a little more than that for a single dose, which is quite expensive as going by Indian standards. So we couldn't use it for every giant cell tumor. During the course of this study, as you will see, which is 2.5 years, we surgically treated 190 giant cell tumors. Out of those, only 44 of them is the ones in which we have used denosumab. That means it's just about 1/4 of the total number of cases that we were seeing. So cases where thought that we proceed with treatment or surgical treatment where denosumab wouldn't really add benefit, we went ahead treating as we always did. What are the cases in which we added denosumab? The first, patients who, when presented upfront, would have actually been candidates for resection, but we thought that with the use of denosumab, we could make them into potentially curatable cases, is one group of patients. The second is patients who were undergoing resection, but because of the large soft tissue component, there was a danger of injury to the surrounding neurovascular structures or inadvertent tumor spillage during surgery. So denosumab would cause an osseous rim, making surgery safer. And the third group of patients was the ones in which we could do a curettage, but there was very little subchondral bone or the soft tissue component in what is called as Campanacci grade 3. And I'll speak of Campanacci grade 3 a little later. The soft tissue component would make curettage dangerous because there was no scaffold against which we could curette. And therefore, while doing a curette, we could cause inadvertent injury either to the articular cartilage or the surrounding neurovascular structures. So we categorically just divided it into these three groups. As I said, the benefit of insight, having known what others would use denosumab or are experienced to use of denosumab. So right from the beginning, we were able to sort of prospectively decide on what would be the intent of treatment if we denosumab.
Now, AJ, who made those decisions? Who decided what each patient was going to get? Who was the actual decider of that?
Okay, so in our unit, in spite of the numbers, we are two consultants, two orthopedic oncology consultants, and we have a host of fellows and residents. So the decision was essentially taken by either one or both of the consultants sitting together. So it was a subjective call, but essentially made by the same team of two consultant surgeons over the duration of the study.
Okay, and then how do you record your data in your unit? Do you have a team doing that for you, and is that actually done at the time? How's it done?
Yes. So now considering that this was what we had planned to do, it was a sort of a prospective decision on what we would do. It was easier in these cases, but in general, the hospital has an electronic record system where the general data of the patients is recorded, and for all unit in which every operated case is prospectively entered. So that's the sort of callback that we look at, either the hospital electronic medical records or the data that our team has entered for each particular patient.
And at what point do you think that did you decide that you were going to do this study? Was it whilst you were doing these cases? Was it before you'd even started doing them, or was it something that you saw once you had a significant cohort?
No, so I think we did recognize the fact that among the global orthopedic oncology units, we were possibly the ones that would see the largest number of giant cell tumors in a short period of time. And this being a relatively new drug, I think at the back of our mind, we always had the intention that we were going to write this up. We were just waiting for a minimum period of 24 months of follow-up for the majority of patients before we published it. Because one of the criticisms of earlier published data on denosumab was that they had a relatively short follow-up period, 10 to 11 months. So no one could actually really predict what would be the local recurrence-free survival. And that's why we thought if we waited a minimum of 24 months before we published our data, it would give us and the global viewer a better idea of what local recurrence could be in these tumors.
Okay, well, so you've got this huge group of patients that you've divided into 3 groups, AJ. So what do you think are the main findings of your study?
All right, so I think people using denosumab, it was thought to be the magic bullet that would help reduce recurrence and give us this great answer to giant cell tumor. But as I said, luckily, we sort of had experience to what others had seen. So we never thought that denosumab would actually reduce the rate of recurrence. In fact, if you see rate of local recurrence is close to about 45% in the cases which we have treated by curettage. But we have to remember that there is a huge selection bias. These are tumors with a large soft tissue component. These are tumors with inherently a higher risk of local recurrence. So it would be wrong to compare them to a group of all comers in giant cell tumors. We need to selectively look at what we call the Campanachi grade 3, which is essentially tumors with a cortical break with a large soft tissue extension. So there is an inherent chance of increased local recurrence. And if you look at global data published in the pre-denosumab era, if you selectively look at Campanachi grade 3 tumors, there have been these, one from, as you said, the ROH Birmingham, another from a group of 10 European hospitals that has shown close to a 35% rate of local recurrence in these tumors. So in that sense, these are tumors which will inherently have a large degree of local recurrence. What the benefit that denosumab added was not in terms of reducing local recurrence, but in making surgery safer and the surgeon more comfortable that he or she had a scaffold against which they could do a more rigorous curettage compared to just having a soft sort of background against which to do a curettage where you're always worried that you may perforate that soft tissue envelope, damage tissues. And in a small group of patients who have otherwise would have had a resection, we were able to convert them to a curettage and therefore retain native bone.
Yes, so this concept of the surround of the rind is important, isn't it? It's the difficult thing, and whether in fact the curettage is made more difficult because, or to get a clean margin or a sterile margin, a sterile rind, it is really one of the areas of sort of conflicts with the use of denosumab, isn't it? And I suppose the next step here is for the group that you've treated by curettage, you've got a local recurrence rate, I think at about 2 years, of 44% in your follow-up period, haven't you? And most people would view that and see that as very high. So one of the statements might be, well, is there not just a case for advocating resection of all these cases instead of just doing an intralesional procedure? What's your view on that?
I think that's a justified criticism. But if I look at it from a different or a contrarian viewpoint, most of these patients are in the second or third decade of life. They have a huge amount of active life left back. So if even with a 44% recurrence, I'm offering more than a 50% chance of them salvaging their native bone, being able to do what we would call a biological resection, then I think it's worth taking that call, especially in a tumor that is only locally aggressive. We would never take that call in a malignant tumor because we know that recurrence in a malignant tumor is synonymous with decreased survival, much poorer survival. But this is a young group of patients with a benign disease who are going to have a normal lifespan. So we do counsel the patient. And I think speaking to the patient is very important in these cases. We give them the pros and cons of both doing a resection and a curettage. You have to know that when we are looking at curettage for recurrent repeat surgery, there is a 50% chance of repeat surgery. If I do a mega prosthesis, there is almost 100% chance of the patient requiring revision in their lifetime. So these two will have a second surgery. May not be for the disease, but for either servicing the implant or having to replace an implant which will fail because of fatigue at some time. So when we balance that, given a choice, most patients, once they understand, opt for a curettage. So I would still say that counseling, speaking to a patient is very critical in this. And at this stage, I'd like to add the advantage of denosumab is that this osseous rind which it creates, especially in the subchondral bone, gives you a second chance at repeat curettage. That means even if there is a recurrence, it does not mean that you would have to do a resection the second time onwards. In fact, in 50% of our patients who did have a recurrence, we were still able to do a recurettage. And fortunately, they have still been disease-free, though I accept that the follow-up for these repeat curetages is relatively short. We need to wait a little longer before we can take a call on that. And if I come back to the point that you mentioned about the osseous rind, over experience, we have learned that the shorter the duration of denosumab, not that it makes curettage easy, but it makes it easier. And in our own series, we have seen that with increasing experience, we now do surgery at almost 2 months or less compared to the 6 or 8 doses that we used to give earlier. So that's something that we learned with experience.
Okay, I'm interested just very briefly to look at the influence of filling the cavity with bone graft and filling cavities with cement, and really the ease by which you can do a recurettage and the ease by which you can identify local recurrence in those two scenarios. Have you any comment to make on that?
Definitely. Technically, it's a lot easier to fill it with cement. Also, though, for a long time we believed that the choice of a filling agent did not make a difference in recurrence. Over the last 4 or 5 years, we've had 2 or 3 series come up that has said that if you use cement, the chance of local recurrence is a little less. The downside of cement is that if you ever require a surgery, and it need not be for recurrence, but it could be, say, for osteoarthritis of the knee, you would not be able to use a normal surfacing implant. You'd need a megaprosthesis. The advantage of using bone in younger patients. In this case, we have used largely cement because there were huge, large cavities with an extension. And we also thought that the little bit of additional tumor kill that we'll get, because there is always a danger that you would leave back neoplastic cells because of that osseous rind, would be better.
How successful have you been? I know your results are not going to play this out very far, but how successful have you been in treating patients with further local recurrence?
So as I said, in the patients with further local recurrence, half of them have required a resection. In one half, we have still been able to do a curettage. And none of the ones in which we have done a repeat surgery, whether a resection or a curettage, we have had local recurrence again. I would still like to sort of a word of caution that we will require a longer follow-up, because the average time to recurrence in our series has been about 16 months is what's mean. And all the patients who have had repeat surgery have not finished that part. So we may still get a second local recurrence, but in half the cases, we've managed to salvage them with a repeat curettage.
I mean, there's one thing that has come up literature, and there's been some comment about it. There's been a little worry about conversion of giant cell tumour to a more malignant form. Have you seen any evidence of this in any of your cases?
No, in our series, we did not see any evidence of this. Also, our follow-up is relatively short. Maybe malignant change takes longer. Our dosage of denosumab was much less than what was given in other series. But in most of the series where authors have seen the occasional malignant transformation, there is still a sort of iota of doubt whether this was initially a giant cell rich sarcoma to begin with, and it was more of a sampling error than actually malignant transformation. So I think we need to sort of still keep this under review before we take a call whether denosumab is causing malignant transformation or not. So it will be nice because a lot of institutes are now using denosumab. We maintain these prospective follow-up, but I would be a little reluctant to attribute malignant transformation to denosumab upfront with the data that is available today.
Okay, so and on the basis really of your findings, Ajay, what do you think the future is for denosumab in the management of giant cell tumour? Is it wonder drug or is it humble assistant? How do you see that?
I think half of one and 50% of the other is what I'd say. So it is a wonder drug. for giant cell tumors that do not have a surgical option. There is a certain number of giant cell tumors, for example, in the axial skeleton, in the spine or the pelvis, that you may not be able to offer surgery to. And then we had a huge problem when we used to treat them in the pre-denosumab era. So these are tumors that will actually respond to denosumab. The only problem is because it does not kill the actual neoplastic cell. But I think that's something that we need to look at, that whether in adjunct with angioembolization, maybe zoledronic acid or some other drug, we can keep these patients on long-term denosumab with a sort of treatment holiday in the middle, adjusting the dosage. That is where denosumab will play a key role. The second part, humble assistant, yes. Judicious use, maybe the 3 cases or the 3 types that we have outlined in our paper, the cases where we'll need to selectively use denosumab, definitely not in all comers, because it does have its downside too. So a judicious use of the patients in which we are going to subject them to surgery, and a large advantage in patients in whom we could not offer surgery at all.
Professor Puri, many thanks for giving us your views and insights into this fascinating area. I'll hand you back now to Mr. Duckworth.
Thank you, Sam.
Thank you, Sam. It's been a pleasure speaking to you.
Professor Puri, it's been an absolute pleasure listening to you both with that excellent, really fascinating discussion. Congratulations, Ajay, on a really excellent study. To all our listeners, we do hope you've enjoyed listening on our guest interviewer, and we encourage you to share your thoughts online and via social media. Feel free to post or tweet anything about what we've discussed here today, and thanks again for joining us.